Now, to really get into the formation of hurricanes, we've gone over the steps that lead into hurricane formation. Now let's get into the formation and structure of the storm itself. What you see here is a white hot center. It's reinforcing that hurricanes are circular heat engines. And you are seeing there the difference between the white hot heat around the eye of the hurricane and the cool ocean underneath it. It's really an amazing look through infrared imagery, satellite imagery, infrared imagery, into the eye of the storm. We are going to reinforce to you that all of this happens. This heat engine drives this storm without upper level supports. There are no troughs that are associated with this to divert off air and maintain that surface low. There are no troughs that maintain a surface high by the converging air that is maintaining the converging blocking high. None of that upper level support functions in these ferocious storms because the warmth around it essentially does all the power for the storms. Let's go in and talk about this in depth. Talk about the fact that these storms don't need upper level support. What we're essentially talking about is that these storms are forming at lower levels in the atmosphere and then moving very high in the atmosphere. When they start at the lower levels in the atmosphere, we're talking around 700 millibars. Remember, when we were talking about mid-latitude storms, we were always looking at the upper level maps at 500 millibars, which is about at the level of the highest Rockies and the highest heights in North America. When we're looking at 700 millibar levels, we're around 2,000 meters up, so not nearly as high. At this area, you have that gentle trade wind action that is moving from east, from Africa, to west in the Caribbean. And you are noting that the converging air in that area is coming from that low pressure system at the surface and coming into that low pressure system and converging up only to 700 millibars and then condensing in that area and forming your clouds on the eastern side of this little bit of a ridge here. And then you have diverging air that is sinking from that 700 millibar level, and then it is diverging out at the surface for a little surface high, not a lot of surface high, clearer air in front of it. So we are talking about the same cyclonic steps at lower altitudes, at lower atmospheric pressures, and we are talking about convergence up into those areas from the surface low and the clouds forming right in there. Get that? Okay. In 3 steps, the convergence and the divergence of hurricanes in this gentle area right around 700 millibars. First step is that converging surface winds pick up the heat and the moisture off of the ocean. I think that makes a lot of sense. The second step is when you get up to about 700 millibars, you have so much moisture and vapor in the air that it is going to saturate out quickly and condense. And when it condenses, you know that you are releasing heat from water vapor to raindrops. That phase change releases heat and a lot more latent energy into those parcels, forcing this to go even higher in the atmosphere with all of this heat. You can start to see how these storms move right up to the stratosphere when they form. When you get to these upper levels, there is so much energy from so much water vapor and so much warm water vapor that you will diverge up into these upper atmospheres and diverge out on its own. These storms do not need a trough to take this off and to diverge this air away in order to maintain the surface low. These storms have so much energy that it is just going to diverge out on its own because there's so much energy there. So this does not, this requires convergence. This requires divergence. It does not require a trough to the west to make sure that these divergent patterns stay in place. And in fact, that fourth part of it is that upper level gentle divergence maintains the surface low pressure because you're moving everything up, leaving surface pressure. Remember, rising slow, clouds and snow, surface low. In fact, when you look at these hurricanes, we're beginning to understand that it is a collection of multi-cell thunderstorms that have converged together in this heat engine, so that when we look into this, we're looking at the same sorts of ideas on convergent air around a low coming up and diverging out in the upper atmosphere, much as an ordinary thunderstorm and then a multi-cell thunderstorm would act. When we look into that multi-cell thunderstorm, in this case, it doesn't need wind shear because of all the heat and all the energy that is moving up there. This is truly a cyclonic storm. This circle is so well founded, whereas in mid-latitude storms, you'll see the trailing edges and a tight circle. In hurricanes, you don't see the trailing edges. You see an entire broad circle that covers hundreds of miles. This is a truly cyclonic storm that doesn't need upper level support. And if you look to the infrared imagery, you'll see the evidence, the data for the multi-cell thunderstorms that result out of this. You see a thunderstorm grouping, another one. These are the heat centers around those areas. You see this heat center rising right up and diverging out as a result of that. And you will see that as that goes up, look at that cool area right underneath versus the warm area that's high above and diverging out. When you look at hurricanes, you have such a tall footprint that you actually have differences in the pressure levels by altitude over this very large altitude difference. So there is divergence here, and there is actually the convergence at the low, converging up in the upper atmosphere, diverging off, but because it does not have a trough out here to pull off the diverging air, there is some pressure that remains high because that divergent flow without an upper level support is slow, and there is a lot of flow that stays right up on top in the stratosphere on top of this column of converging air that's rising. What is amazing is that now research is beginning to show is the formation of the high. This area actually will produce high pressure that will start to sink. And remember, we say sinking sky, warm and dry, surface high. Well, what you have here is you have an eye forming of a dry area without clouds pushing down as the converging air is coming up. This really, those two forces acting against each other really reinforce the walls of the eye. And we are still doing research to understanding how these two forces converging and then sinking act in the strongest hurricanes. You want to do some research on hurricanes? There's a perfect area to learn. We have to learn a lot more about the eye, but it's a combination of rising slow and sinking skies. That's what there is to look at. Then when we look at what keeps this hurricane moving and growing, there is a pressure gradient force here at the surface. Let's look into that a bit. You have air that's converging up and diverging out. Then that divergent air will eventually sink. Remember, sinking sky, surface high, not much of a surface high, but there is high pressure here that is moving from, on the pressure gradient force, from the high pressure to the low pressure, speeding up those winds. So there's where you get the heat engine becoming a wind engine. It becomes a surface pressure gradient force from the high pressure, from the sinking skies, to the low pressure right around the surface low pressure and the bottom of the eye. That's where you will note here that the surface air pressure tends to be high at the sides of the hurricane and tends to be very low, bottoming out right under the eye of the hurricane. You can see that this is a pressure gradient force that's going to drive from high pressure into low pressure and drive those winds. And as a result of that, look at the wind speed change from the side of the storm into the eye wall of the storm. A dramatic increase in wind speed in those areas. What we still need to understand is this dramatic drop in wind speed in the eye. If you look at this from a satellite, look at this amazing eye in here. This eye actually has levels to it that really show you what's called the subsidence, the sinking inversion, and the sinking area that is dry and cloudless. So that's where you are seeing your subsidence inversion, your sinking sky. And here you're seeing your spiral rain bands moving in with your multi-cell storms that have, between the multi-cells, they have sinking sky areas that are rain free. So around each multi-cell, you will get a downdraft that will essentially be sinking sky and have its own little eye in here. Amazing. When this heat engine is removed from its watery area, its watery fuel source, it's dead. And in fact, this is an infrared image of how land destroys this low friction heat engine. Once it moves onto land, all of that stratospheric build just collapses because the heat engine is gone and there is no upper level support. So that's what land does to a hurricane. But if you are in the area along the coast that is still fed by the hurricane in the ocean, you get the worst part of the storm. Let's go to some more soon.